Yeah, exactly.
Which one is yours?
No.
No project.
Ah, I understand.
No projector.
Yeah, I remember.
Listen.
Thank you very much. Well, as usual, the last speaker. That means it's my pleasure and my privilege to thank the organizers, local organizers, all functionaries of the society for organizing yet another great meeting. It's always a pleasure to be here. And so far, at least, everything I've seen was of very high quality. All right, so this is joint work with Salvador Barbera, and the topic is in voting theory. Well, we phrase it as a problem in voting theory, but it has its applications in any context where we have some sort of aggregation problem from starting with individual preferences, and we want to make social choices. More precisely, we look into what's known as Condorcet consistency. And I guess most of you are familiar with this concept. If not, don't worry, I'll define it formally. Basically, this topic goes back to more than 2 centuries. And Condorcet was proposed the use of the majority rule. First and foremost, he said, well, if we have a situation where there is a candidate who beats every other candidate individually, pairwise, in a majority vote, then we should acknowledge that this candidate has very privileged standing. He or she should be elected, and we're done. By the same token, if there is a Condorcet loser, that is a candidate that loses against every other candidate in a pairwise comparison, then the conclusion is this candidate should never be elected. These are fairly uncontroversial statements and requirements. One problem with them is that very often they cannot be applied because, as we all know, the majority rule is not transitive in general, not even basically, unless you have a lot of help from your domain. And therefore, we think it would be desirable to try to go a little bit further, that is, come up with something that's almost as uncontroversial as Condorcet's original proposal, and yet has some reasonable properties when interpreted as a consistency criterion that is based on the notion of an alternative being, or a set of alternatives being in a reasonably privileged position to give them special treatment. Now the first obvious choice is to move away from what's called, what I just described is also called the strong Condorcet winner criterion and loser criterion. Go away from the strong part and consider candidates that beat or tie with every other candidate. If you do that, you end up with what's called weak Condorcet winner consistency and weak Condorcet loser consistency. But there is a problem right away, because a candidate can be a weak Condorcet winner and weak Condorcet loser at the same time, and then you're in trouble because you cannot say this candidate should definitely be elected or should never be elected. So our suggestion is very simple. On the surface, we say, well, just look at the weak Condorcet winners that are not at the same time Condorcet losers, or weak Condorcet losers that are not at the same time Condorcet winners. In a nutshell, what we say is, well, instead of looking at a bunch of weak inequalities, insist that at least one of them should be straight. Again, sounds very, very simple. Yes, even though, I mean, in a way, if I describe it, it is simple. Yet, the properties of such a principle, depending on whether you use some weak or strict inequalities, may differ dramatically. And we're not alone in that. There are precedents in the literature. For example, my favorite example is a notion of a coherence property of a binary relation that's intermediate in strength between transitivity and acyclicity. Was proposed by the late Kogoro Suzumura. He called it consistency, and it basically says, unlike in contrast to acyclicity, remember, rules out the existence of strict preference cycles. Kogoro proposed to strengthen this by saying, well, we should rule out not only strict preference cycles, but all cycles with at least one instance of strict preference. That's stronger. That's not as strong as transitivity, unless you have completeness and reflexivity thrown in. And yet, the difference between the properties of Suzumura consistency and acyclicity are very profound. For example, it is true that Suzumura consistency is necessary and sufficient for the existence of an ordering extension. Previously, it was known that transitivity is sufficient, but not necessary. And furthermore, as another example for very stark difference, is that consistency in Codero's sense allows for the existence of a closure operation, just like the transitive closure is the smallest transitive relation that contains a given relation. There is a consistent closure in the sense that for any relation, there's the smallest consistent relation that contains. No such thing exists for acyclicity or for quasi-transitivity, and this difference can be very, very significant, for example, in the context of rational choice, because if you have something as a closure operation, you can say that with confidence that some property to get some rationalization is that it has to respect observed choices, revealed preferences, not only those, but also whatever in your coherence properties such as consistency or transitivity entails. You cannot do this with acyclicity or quasi-transitivity, which means, again, unless you have a lot of help from your domain assumptions, dealing with rationalizability in the context of acyclicity or quasi-transitivity can be a real pain in the arm. Again, I mean, it's just not the topic of my talk, but I just wanted to use this as an illustration that seemingly minor twists, like switching from a weak inequality to strict inequality, or switching from a weak preference to strict preference, can make a profound difference. Okay, so I already mentioned we go back more than two centuries to Condorcet. If we have time, I hope we will. I will also talk a little bit contribution by Pierre Benoît, who was a contemporary of Condorcet's and a strong supporter of his ideas. And a little more recent history, let me also talk a little bit about some proposals by Duncan Black in the mid-20th century. The methods we use in this paper are very elementary, so no rocket science here, and most of what I'm going to be doing today is essentially definitions and examples. And the examples play an important role because we use them to compare our proposal of a property that generalizes Condorcet with others that have appeared in the literature. All right, so the basic setup is another thing that those of you who've been here before will have noticed. I can be very clumsy, so it will probably happen more than once tonight. By accident, step off the podium. So we start, I will phrase what we do primarily in the context of voting, but again, any preference aggregation problem can be a part of it.